Hi dear students, let's see this question that came in JEE Advanced Paper 2 Physics in the year 2020. This was based on the concept of mutual inductance in a circuit based question, and hence many students would have been they would have left this question, or simply they would have been confused, or they would have left this question. The reason is that not that this question is difficult, but most students do not practice mutual inductance based question on the circuit. Hence this question would have been slightly novel in that sense. Let us see what is happening over here. There are two circuits. The flux of the both the coils are linked. Hence the mutual inductance has been given, which is 5 millihenry. Now when we close both the circuits, we have to find the work done by both the cells against the EMF of the inductors. So basically we have to find the energy stored in the inductor. That essentially will be work done by the cells against the EMF of the inductors. Now when we close the circuit, it is easy to see that finally the steady state current in the first circuit will be 5 upon 5, which is 1 ampere, and in the second circuit it will be 20 upon 10, will be 2 amperes. This will be the steady state current. Transient current, of course, that means time varying function will be I1 over here and I2 over here, both will be time varying functions. Now if I say that, let's say in dt time how much work is being done. So dw1 is the work done in against the EMF of this inductor in time dt. So can I write this dw1 as E1 I1 dt? Like power is vi, power is rate of work being done. So dw1 by dt will be EMF of this into I1, right? Now it will be interesting to see how do we write E1. So E1, if you see carefully, can be written as L1 di1 by dt plus or minus m into di2 by dt. Why did I write plus or minus? Because we are not sure whether the flux of second coil is in the same sense as the flux of the first coil. That means it might happen that flux of the first coil is going from up to down, magnetic field lines are being created in this direction, but the flux of the second coil, which is passing through first coil, might be going up, right? So that cannot be ascertained by looking at the windings. So if this is the scenario, then it will be minus. On the other hand, if the flux are both the fluxes are going in the same direction, then it will be plus. Okay, so this is the anyway. So but see, the practical utility is that if we take if we take plus sign, the reason is that we do not want to decrease the inductance. No, practically it will be more useful if the inductance is high, so that more energy can be stored. So ideally the plus sign makes more sense. Okay, but anyway, I'm going to compute the answer using both the signs. So E1 is this. So if you see what is dw1, if you put this value, dt will come over here. So this will become L1 di1 into I1, okay, plus minus m into I1 into d of I2. Okay, symmetrically speaking, we can write dw2 as L2 di2 into I2 plus minus m into I2 into di1, right? So if you add these two and integrate it, so we can say that w1 plus w2 will be equals to integral of L1 di1, okay, into I1 plus integral of L2 I2 di2 plus this, you can see m we can take outside, di1. Let me write on the next slide. This will be slightly okay. So w1 plus w2 will be equals to integral of L1 I1 di1 plus integral of L2 I2 di2 plus m will come outside, I1 di2 plus minus, no, here it will not be plus minus, here it will be plus minus, okay, plus I2 di1. Make sense? So if you integrate this, you can see that this will become half L1 I1 square. So half L1 I1 square. This will become half L2 I2 square plus or minus m d of I1 I2. You can see this is written d of I1 I2. That will become I1, I2, right? So when you put the values, now we can put I1 as 1 ampere, I2 as 2 amperes. So you just have to put the values, I1 as 1 ampere and I2 as 2 amperes. M is given and L, everything is given. So you'll get your answer in millijoules because they are millihenries. So if you take plus sign, you're going to get 55 millijoules. If you take minus sign, you're going to get 35. So this will become, this comes out to be 45 and this comes out to be 10. So 45 plus 10 is 55 and 45 minus 10 is 35. So again, as I said, plus sign makes more sense because we would not want, inductance to decrease. Okay, hence 55 should be the better answer. Yeah, in fact, it is the better answer because IIT finally released the answer and they chose only 55. So that's it. Thank you.